So the commutative property of multiplication, and yeah, that should be a familiar word. We had a commutative property for addition as well. And again, this is just saying that if you want to do a certain part of the multiplication first, you can, which is, you could say it's the associative property, but it means that you can move these values around, right? And yeah, it doesn't have to just be between two values like we're seeing here with A and B. It could be 3 values or 4. You can switch those around as much as you'd like in order perhaps to create more convenient products moving from left to right. So yeah, order does not matter with multiplication, just like it does not matter with addition. For example, yeah, 5 groups of 10 would be 50, or if you had 10 groups of 5, still 50, right? And yeah, if we look at this in more concrete examples, if you have 5 $10 bills, how much money do you have? And yeah, that would still be, just like we see above there, it'd be $50. So if you had 10 $5 bills, how much money do you have? Still $50. I mean, I put it in a different color there, but hopefully that's not a problem. So yeah, and again, this last part, it works with more than 2 values. There is no commutative property with division. All right, so if you see division, switching those back and forth is very different. And I think we'll see that kind of with the fact family stuff. You could use a concrete example, right? You could say, well, if you took 10 and even dividing it by 1, like this, you say, okay, anything divided by 1 is 10, and that's pretty good. But if you switched them and you said 1 divided by 10, well, that's a number that's less than 1. It's not even as big as 1. So they're not the same. All right, and we'll get into the actual value of what this would be later on. That's not a 0, it's more like a box. Something would go in that box. We're just not concerned about that right now because we have not covered decimals or fractions. All right, so looking at these 4 examples, we just need to identify which of these demonstrates the commutative property of multiplication. I think this is a good point to take a minute and see if you can identify those for us, all right? So just take a minute, look at them, and identify which of these demonstrates the commutative property. 1 minute, and then we'll go over it, okay? 1 minute, go. Well, let's go ahead and go over that, okay? Now, when we see the commutative property, we should see a change in order. And yeah, some of these may look familiar. Like this one right here, this is the bottom one. I'm just kind of picking these randomly, I know, but this bottom one right here is not the commutative property. That's the identity property of multiplication, which we've just seen. 2 times 1 is itself, right? It's the identity. Now, we haven't talked about this one, but anything times 0, right? If you had 2 groups of nothing, you'd still have nothing, like this, okay? And we'll get into more details about that. I don't know that it goes beyond what I just said, but it doesn't really change the order. I mean, it kind of got rid of the 2, but we need to see that 2 if we want to use the commutative property. So that one doesn't work. And then this third one right here, we have 2 times 3 and that times 6. And then 2 times 3 times 6. See how the order didn't change on this one? I mean, the location of the parentheses did change, which will be its own property here in a moment. But the order didn't change, and that's what we need from the commutative property, and that would be the top one. Here we have a 2, then a 3 multiplied. So then the 3 and the 2 switch places, and so that's the commutative property right there. This is, the top one is the commutative property of multiplication.